So you can think of geometry as a place or a playground or an opportunity to investigate patterns, develop methods of your own in order to solve problems and answer questions. So one classical question in geometry is, what are the sum of the angles of the inside of a polygon? And so we know that when you have a triangle and you add up the three angles inside, you get 180 degrees. We should know that any rectangle or square, when you add up the angles inside, you're going to get 360 degrees. But is there a pattern there that we can establish? What about a pentagon, a hexagon, a heptagon, and so on and so forth? So I'm going to help you develop a strategy using something that we know, which is the area, or not the area, the angle measure of a triangle will always add to 180 degrees. So let's start using that idea to find out. Let's suppose we have a square. We know 4 right angles, those will add to 360 degrees. But we also know we can divide that square into 2 equal triangles. And a triangle, of course, will have angles that add up to 180 degrees. 180 times 2 is 360. So let's see if we can continue to extend this strategy. Let's take a pentagon. So unless you've read it before or engaged in this activity before, you probably don't know what these angles are going to add up to. That is, if I add these 5 angles together, what will their measure be in total? But let's use the strategy of drawing triangles. I can definitely create 3 triangles inside of 1 pentagon, and I know that inside of each triangle we will add to 180 degrees. So that means the sum total of all of those angles in the pentagon will be 180 degrees times 3. You're welcome to check that on a calculator if you want. It is 540. So let's continue on. What about a hexagon? Well, let's employ the same strategy. How many triangles can you create inside of a hexagon? 1, 2, 3, and 4. And of course, each of these triangles has angle measures that sum to 180 degrees. So the total measure of all of these angles, when you add them together, will be 180 degrees times 4. And 180 times 4 is 720 degrees. And so you could continue this on with a 7-sided shape, an 8-sided shape, and so on and so forth, and then ultimately try and develop a rule of your own that you could use right down here for the n-gon, as we call it. A rule that would work for any shapes. So there you go, a little bit of an introduction into geometric reasoning.